When the aircraft plummeted from sight, less than a minute after liftoff, the aviation world went silent, and the industry was forced to reevaluate assumptions about technology, redundancy, and human factors. On 12 June 2025, Air India Flight AI-171, a Boeing 787-8 Dreamliner registered VT-A&B, departed Ahmedabad for London. Seconds after rotation, the airplane began to lose thrust and plunged back toward the airport perimeter. It crashed into buildings near the runway, killing hundreds on board and on the ground, and leaving only a single survivor. The Aircraft Accident Investigation Bureau's preliminary report identifies a startling proximate finding. Both engine fuel control switches moved from run to cutoff in the first seconds after liftoff, resulting in immediate loss of thrust and the catastrophic descent. This shocked the aviation industry because the 787 program had been widely viewed as one of the most advanced and reliable modern widebodies, with composite structure, sophisticated FADC-controlled engines, and extensive health monitoring sensors. A sudden, near-immediate loss of both engines at takeoff strikes at the heart of aviation safety assumptions. Redundancy is only as effective as the combined reliability of the systems and controls that enable it. That's the central question this investigation is now probing. To evaluate what happened, we need context: the airplane, the operational environment, and the regulatory and commercial stakes around the 787 program. First, the airplane. The Boeing 787-8 is a long-range twin-engine, twin-aisle Dreamliner variant that helped reshape long-haul economics with lighter composite structure, advanced electrical architecture, and efficient turbofan engines. Typical 787-8 characteristics include large fuel capacity and long-range capability, a high-technology flight deck with FADC-controlled engine systems, and integrated health monitoring intended to flag faults early. For airport planning and performance reference, Boeing publishes the 787's design and weight figures used by airlines for dispatch and climb performance modeling. Second, the operating environment. Ahmedabad's Sardar Vallabhbhai Patel International Airport handles heavy international traffic with standard runway and obstacle constraints. The accident flight was at or near maximum takeoff weight with substantial fuel for the long sector to London, meaning the aircraft's climb performance and energy margins were determined tightly by weight, thrust, and configuration at liftoff. Those parameters are critical when an engine issue occurs in the immediate takeoff window. Third, commercial and program stakes. The 787 is a major program for Boeing and its supplier ecosystem. Any hull loss of this magnitude, particularly the first fatal hull loss for the type, triggers immediate regulatory attention, potential service bulletins, and market uncertainty that can affect airline schedules, lessor portfolios, and manufacturer orders. We'll unpack those financial and operational impacts later. This is the forensic heart of the episode: what the preliminary evidence shows, what it implies technically, and what areas remain open. The AAIB's preliminary report, compiled from flight data recorder extraction, cockpit voice recorder transcripts, wreckage examination, and recorded ATC communications, reports a concentrated sequence. The airplane rotated, liftoff occurred, and within a matter of seconds, both engine fuel control switches moved from run to cutoff. Engine 1, then Engine 2, separated by approximately 1 second, followed by immediate decay in fan speed and available thrust, and a rapid loss of altitude that culminated in the crash minutes later. The report is explicit that the movement of the switches was the proximate event that removed fuel flow to both engines. The document stresses that this is a preliminary factual account. It does not assign final causal responsibility for why the switches moved. Why this is such a crucial factual anchor? Fuel cutoff switches are the direct mechanical or electrical control that stops fuel flow to the engine. When the control is placed to cutoff, the engine flames out within seconds. In normal operations, those switches are in run. An observed near simultaneous movement of both fuel cutoff switches during a critical flight phase is therefore a high priority anomaly for investigators. Here's how this works in practical terms. Modern turbofan engines are governed by FADC, which manages fuel flow, spool speeds, and thrust settings automatically. The FADC cannot deliver fuel if the fuel control hardware, including the fuel cutoff selector, fuel shutoff valves, and associated electrical and hydraulic actuators, is commanded off. In most flight decks, the fuel control switches are guarded mechanically and are part of a layered system intended to prevent inadvertent shutdowns of an operating engine during critical phases. A movement of the fuel cutoff selector to cutoff can be accomplished by mechanical actuation or by an electrical signal in some architectures. The AAIB preliminary report documents the switch positions and the resulting engine behavior. What remains to be determined in the final investigation is whether the selectors moved due to mechanical actuation, intentional or inadvertent by crew, maintenance, or stuck control, an underlying electrical control anomaly, or an interaction between systems and maintenance history. The investigative path now includes trace examination of switch assemblies, wiring harnesses, maintenance records, and simulator reconstructions to rule in or out each pathway. From an aerodynamic and energy state perspective, the situation was essentially unrecoverable once both engines stopped producing thrust at low altitude and high gross weight. The 787-8's climb performance at maximum takeoff weight depends on available residual thrust and climb angles. Without thrust, the aircraft's glide ratio, wind, and altitude determine the distance it can travel before impact. In AII-171's case, the engines lost thrust within seconds of liftoff, and the airplane failed to clear the airport perimeter wall and nearby structures. With so little altitude to trade for energy, options like returning to the runway or successful forced landing outside the airport were not feasible. The preliminary timing in the AAIB report, from liftoff to fatal impact in roughly half a minute, makes the constraints starkly clear. Preliminary cockpit voice recorder excerpts and CVR-aligned timeline indicate immediate cockpit awareness of engine anomalies, urgent callouts, and rapid degraded mode checklists being attempted. The AAIB report includes CVR-derived timestamps tied to switch movements and engine instrumentation changes. Investigators are now analyzing crew actions in context. Were the selectors manually moved? Were they toggled accidentally during a rapid contingency maneuver? Or was there an electrical or instrumentation fault that translated into switch movement or a false indication? The AAIB is also examining training records, standard operating procedures, and human-machine interface ergonomics to assess how likely inadvertent selector movement might be during the high workload takeoff sequence. At this stage, the public record documents the observed sequence, but not the definitive human factor conclusion. The implications of this event are immediate and multi-layered: certification and regulatory scrutiny, airline operations and fleet availability, manufacturer and supplier liability, and broader market impact. First, regulatory and certification scrutiny. A first fatal hull loss for the 787 triggers urgent airworthiness actions, mandatory inspections, targeted ADs or airworthiness directives, and potential service bulletins for affected systems. Regulators typically coordinate with the aircraft and engine manufacturers and may ground or restrict fleets pending inspections. Early evidence indicates authorities ordered additional maintenance and inspections on Air India's 787 fleet, and other operators initiated voluntary checks. Second, operational and financial consequences for the airline and others. Air India temporarily reduced some wide-body international flying and took aircraft out of service for inspection. The airline and its lessors face aircraft hull loss accounting, claim settlements, and reputational damage. For the manufacturer and supplier ecosystem, market reactions were immediate. Boeing faced intense scrutiny and financial market sensitivity as investors and customers weighed program risk, while insurers and lessors reassessed exposure on similar types. Historically, such high-profile accidents produce a combination of immediate liquidity and PR cost, plus longer-term commercial impacts on orders and lease values until confidence is restored. Third, engineering and training responses. If the final findings isolate a systemic vulnerability in the fuel control system, manufacturers may issue hardware or software modifications. Operators will adopt new inspection regimes, and training syllabi will evolve to emphasize any identified human-machine interface risks. Even if the root cause is a maintenance oversight or an isolated failure, the cascade of policy and practice changes in fleet maintenance protocols, cockpit ergonomics, and redundancy checks is likely and appropriate. Targeted technical fixes and restoration of confidence. If the final report identifies a localized hardware fault or wiring defect that can be corrected with parts replacement, procedural changes, or software updates, regulators will authorize focused airworthiness directives, and operations will normalize over weeks to months. That outcome would limit long-term program damage, though short-term operational disruption and reputational cost would remain. Extended scrutiny and phased groundings. If investigators find a design or systemic failure requiring broader hardware redesign or lengthy inspections across global operators, regulators could mandate wider, time-consuming inspections or operational restrictions. That would raise repair costs, increase fleet downtime, impact schedules, and would likely pressure Boeing's program economics and supplier commitments. Market indicators and order dynamics would reflect that extended risk window. Operational and training changes as enduring outcomes. Regardless of the specific causal answer, we expect sustained emphasis on cockpit ergonomics, switch guard design, maintenance records visibility, and simulated training for sudden dual-engine loss scenarios at critical flight phases. Changes that improve safety across types. These are lower costs but high-value mitigations that operators and regulators typically embrace. These scenarios are conditional on the final AAIB and international investigative work. The industry's response will map to those findings in a measured, evidence-driven way. To sum up, the preliminary record shows a terrifyingly short sequence in which both engine fuel cutoff switches moved to cut off seconds after liftoff, producing dual engine loss and an unrecoverable energy state that led to the aircraft crashing near Ahmedabad. That factual core is the anchor for the ongoing investigation. Why the selectors moved, whether mechanical, electrical, human, or some combination, remains subject to deeper forensic work. The consequences are already visible in regulatory inspections, operational adjustments, and market reactions. The industry will learn and adapt. The question now is how fast and how comprehensively those lessons are implemented to restore confidence and prevent recurrence. Journalistic disclaimer. This episode is grounded in the AAIB preliminary report and contemporaneous reporting from major outlets. Where the record is incomplete, we do not speculate beyond what the investigation supports. We will update this coverage as the AAIB releases final findings and as manufacturers and suppliers publish service actions. If you want a dedicated technical deep dive, a scene-by-scene cockpit reconstruction, an engineering explainer on fuel control architecture, or a market analysis of Boeing and the 787 program after this event, leave a comment. Remember to subscribe for more aviation content, hit like if this breakdown helped you, and ring the bell to catch our follow-up reports.